Hello and welcome to the channel. So this is part 2 of the mystery tube amp that we had on a few weeks ago, and we're going to get this amp fixed up. So we need to remove this boggin, you can see here, and we're going to put a IEC in there. We're going to put a better ground in there because that one's just ridiculous. In fact, it's almost off anyway, and it's not a good enough connection. Rewire this switch. Fuse holder was broken, so we're going to do that as well, and just concentrate on making it safe to start off with, and then we're going to work through this amp, just looking for things that need to be changed. We're not changing the main filter caps because they're absolutely fine. This amp was silent. We're going to replace these capacitors here, and there's only someone I think has replaced that. Or was that been replaced? Maybe not now. So we're going to replace this cap. Not sure what they're doing at this moment in time. And then if I remember, there's no cathode bypass capacitor on the output tube, so I'm going to fit one of those just to give it a bit more oomph. And we're going to do something with this resistor here. So you can see this resistor here is we can't be having that, can we, flopping about. So in fact there's another one there. That one's a bit more secure though, actually. That was going to ground, actually, that one. Oh, it'll be the cathode resistor, of course it is. Duh. Yeah, there's the cathode resistor. There's no cathode bypass cap on there. I'm just trying to get my head around it again. I've not looked in it for a few weeks. Clean these sockets, although they don't look very good. We might have to change those. They're weird looking sockets, they are. And then we'll just check and see if there's any of the plate resistors frying or anything like that. And I think that'll do. There's not a massive amount to do on it. There's enough, but not a massive amount. And then we've got this. We're going to have a look at the connection to the speaker, see if that needs to be changed as well. Right, I've done some work to this amp. So we fitted the IEC. That's the boggin type that fits in the hole. We fitted that. We've got a new fuse holder. We've got one speaker socket now instead of two, because I've had to run some power cables to this switch down under here, and there was a risk that if that came loose and someone tightened it, it could cut in. It was sitting right close to the chassis and it could cut into the cable, so I've just removed it. One's plenty anyway on this amp. I've rewired the speaker socket as well, and I've used this. I've tried keeping this away from as much of the AC away from the DC. Not what's easy in these amps, but that goes across there, that like that. We've wound it tight, so all is looking good. But we now need to fit an HT fuse, and we need to get rid of Mr. Wobbly here. He's the drop-in resistor between the first node and the second node, and he's got to go. So we need to put a tag strip somewhere, and we need to get that resist a small. We don't need a 10 watt in this, blimey, that's just huge. So we need to get a smaller resistor, 1.5k. If I remember, the screens were a little over on this, so I'm going to put 1.5k in. Should just about balance us. This wasn't a lot over, but while I'm doing it I might as well. Right, we've done a bit of a modification so we can get rid of Mr. Wobbly there. So we've added the fuse holder onto there, fasten that on with a couple of stanchions, and then we can put our drop-in resistor to the screens there. So we'll wire the B plus in here, the HT, and go across the fuse to the center tap, and then will go across there and then off here from the screens, and that should be most delightful. It's much safer than that, isn't it? Let's face it, that's the soldering iron's warming up and he's going to be removed. And we'll just, this set out as well with these screens is wired up a bit strange. We've got the centre tap wired into the screens there. Not quite sure what's going on there, to be honest. I'm going to have a bit of a look. I'm going to trace some things out and see where, because yeah, this coming off here. Oh well, that is coming off the screen. So what's this? Centre tap. That's very. So we've got the centre tap wired to the screens, but then we've also got the second node wired to the screens. I think this is, I'm sure this amp's a kit amp someone's put together. There were a lot of those years ago. Right, so we've done quite a bit more on this amp, and there's some things we've had to change because of safety. So rewired most of this section here. Now I've got the screens rewired up, but if you look at this socket here, I'll just go over the top, you can see how it's flush to the chassis, and I've actually drilled it out because we've got to remove it. These pins are almost touching onto the chassis there, so it's not quite safe. That one was the same. I've just changed that one. Now from what I could make out of this circuit, from this EF86 up to here, we've got an EF86 and a long tail pair. But some of this wiring, with this probably being a kit amp, is really suspect. A lot of burnt things and poor soldering. So what I've decided to do with this is to have the EF86 and then a stage and then a cathodione for this amp, as we're doing it for guitar, and just rewire it because it's just all over the place. It's just really poor. So that's what we're going to do with that, and we're going to change this socket. This is for the rectifier we've just looked at. We're going to change that one as well. We've got this thing ready to fire up, so just show you some of the bits that we've done. We've got the 5E3, it's very similar to a 5E3 on here. We've got the, I've used the schematic, used the phase inverter from the 5E3 scheme. We've got this gain stage here, and then we've got this EF86 feeding into it, all wired up, ready to go. Let's see what we've got now. These, all of this tone stack and everything else is before the first stage of the EF86, but I'm going to leave it for the time being and just see how well this amp performs, because it might be okay if we could get those tones working. Right, let's switch on. Right, starting to get some voltage now. I've got 80 watts of bulbs in there. We've got 208 volts going on. Very quiet. Right, see what oh, we've got something. We'll get the guitar plugged into it. We'll scope it out later. My word, that's a bit bassy, isn't it? that's better. So the tone controls obviously still don't work, they didn't before. Yep. So as you can see, I've rewired this amp, and the reason was it was such a mess in there. There was so much. Don't need that now. There was such a mess in there, and everything was burnt and mashed up and just a mess. It was just quicker to rewire it than try and figure it all out and see if it was actually going to sound any good. We've just used a bit of a known diagram there, and at least that's up and running. I'm not sure about the other channel, but that's obviously very muddy. It's all down to what's going on in here, which we may have to look at. But it's running. Now I've got no bypass caps on this. We've got no bypass cap on the output tubes, and I've got no bypass caps on any of the stages. I have got this coupling cap here, and that's not so much coupling cap, it's from the grid, from the screen to ground, sorry, which you generally have on those EF86 as a standard thing. Put a capacitor from grid 2 to ground, it just boosts things up, so we've got that. Let's put another bulb in, shall we? Actually, we'll just flick it off the current limiter, it'll be okay. There we go. Watching that, 310 milliamps we are drawing. The mains. Got a little bit of frying there. Could be one of the tubes. Now we need a grid stopper on that first stage as well, because I hadn't actually altered that. It's still wired in from when I started, so I've just got to drop that in there. 33k will do. So we need that, but it's very muddy with those tone controls. That channel's not so bad, the other one's dreadful. Let's try the other one again. Actually, that. Sound too bad, apart from the out of tune guitar. We've got a bit of noise there. We've got 332 volts on the first node. What have we got let's see what we've got on the screen here. $315. So what we got on the plates, we can go here for that. Here will do. 320. So that's spot on. Not bad at all, that. Not bad. So we need to check the bias, don't we? That's the other thing. So to check that, we need to get the reading across the cathode resistor first of all. Got 10.75 volts there. Not sure what that says on there. We'll have to measure that. Let's switch it off. Better to measure it anyway. Then we know we are right. 121 ohms. That took a bit of settling. Right, let's see what that gives us. 88 milliamps divided by 2 equals, take away 5%, 42 milliamps per tube. 13.25 watts. Oh dear, he's a little bit over, isn't he? You'll probably want a 150 ohm resistor in there just to bring that down. But other than that, it's running. Right, I've put a 180 ohm resistor in there on for the cathode and 22 microfarad bypass cap, and we've got the bias at 10.68 watts, which is, I think, is just about right for this one, so that'll do nicely. Still got that noise, so we're not sure about that. So now we need to turn our attention to these volumes and tones and try to get those working. So now we're still shy of some bypass caps as well. We've got no bypass cap on this first stage. We've got no grid stopper either on that. On the first stage of this pen, well, the only stage, this grid of this pentode. So I left that off for the time being because I didn't know whether I was going to be ripping all this out or not, but I don't think I am now. Right, I've got this amp on the scope. You can see there we've got a few issues with this amp, and it looks like we're going to have to rewire all these pots. I'll explain why that is in a moment. That's flat out. So that's just picking the signal up straight through the speaker outlet there. You can see that looks pretty good. You see we get the crossover distortion there. But that's almost flat out at that. 33, 34 volts peak to peak. So let's have a look at each side of the phase inverter now. Right, so that's the phase inverter, and I've actually inverted one side on here so you can see the match. If I just drop that down, you can see. So that's a pretty good match. Let's see what it's like. Let's go up to 10 volts. You can see there as it gets louder. Turn it up. You see there's a little bit of mismatch there going on. So one side is squaring off before the other. But it's a reasonably, that's really only right at the end of the volume. Go back. Yeah, about 27 peak to peak. So that gets a little bit uneven when it's cranked. $28. Yeah. So they're about the same there. Let's just crank it some more. So we've got 54.4 volts peak to peak for both of them. Let's turn off 54 on that one. $58 on that one. So a little bit more coming out one side than the other when it's, but only when it's really cranked up flat out. Right, now we've got this problem. If you watch on there, there, you see that? There. So I've slowed that down. Now that you can hear if you listen. There, you can just see it occasionally there. There's a big one there. There you go. We've been chasing that for a while, and I think we've tracked that down to the EF86. Now we've you see there's another big one there. We've changed the tube on the EF86. We've changed that tube a couple of times. Now I'm monitoring that from the speaker there. So I'm now going to go to one side of the phase inverter. You just have to change this because we've not got enough gain now. There it is. So still there. So now if we go back, that's going into that first stage now. That second gain stage after the EF86. You can see that there, and that's telling us that doesn't look very nice, does it? What's coming out of there? There it goes again, and that's telling us that that EF86 is the cause of that. Because if we'd have tracked back to the EF86 and we didn't see that, then we'd know it was further down the line towards the output stage. But that, and I think that is the tube socket that's causing that problem, because I've swapped the tube a few times. Don't know whether you can hear that, whether it coincides with it. There's a little bit of latency when it there, see that? So we need to sort that out as well. That's another problem. But the other problem is that the volumes are turned right down now, and you can still hear the background pretty loud. It's as if the amp's turned flat out, and that's because of the way these pots are wired, this whole EQ thing. It's all before the first stage of that EF86, which is just how they've wired this up. Right, so that's as far as we've got with this amp. We've had it on the scope. We've got pretty good signal coming out of there. I did try some negative feedback on it. It didn't make no difference on the scope virtually, so I decided not to bother. So where are we at with this amp now? So we've got this, we think this EF86 is a noisy tube socket, which is causing that problem we saw on the scope. And we've got these, the way these are wired is all wrong really for this amp. So we've got the full background noise of the amp. It's like the amp's turned up flat out even when these volumes are down. So I think what I'm going to do now, I've got a few options going on here, and what I'm going to do is have a word with the customer. I'm going to release this as a part 2 video and see what comments I get from people. So here's one idea, is to get rid of the EF86 and put a 12AX7 in there and then wire this up completely as a 5E3. The reason for that is we've got on the front here, we've got these 4 input sockets like we have on a 5E3. On there you can see we've got 1, 2, 3, 4 on there. Probably, well, you can see that under the lights, but and it's not a great schematic anyway. But we've got 4 sockets there, 2 volumes, 2 tones. We can just have 1 tone that we don't need, so we could lose one of those, have a 12AX7. The problem is with an EF86 is that of course we can only have 1 channel going in there because there's only one, that's just 1 gain stage. So that's the other option, is to keep the EF86, which wouldn't be a bad idea. Get rid of a volume and a tone and just have a single channel going into it, and then just blank off all the rest of these holes that we'll have. So they're the 2 choices: get rid of the EF86, put 12AX7 in there, or keep the EF86 and just remove a few controls and have a single input. I think I prefer the EF86, to be honest. Let me know what you think in the comments, whether you go for the EF86 and a single channel, or we'd have each a volume and a tone going in, 1 volume going into one side of the 12AX7 like we've got on the 5E3 schematic. So that'll do it for this one. So thanks for watching, you all take care, and I'll see you all in another video. Bye bye for now.